Thank you for joining the February 11th, 2020 VOLTA call. Just a reminder to everyone that our meetings are public and recorded, and we post them to YouTube after the meeting concludes. So please be mindful of that during presentations and during discussions today. And then starting off today, we're going to have some discussion from Andrea about patch coordination. There's a proposal I believe he's going to present on the call. Then following that, Saurav is going to give some discussion on regression testing. And then we have just a handful of new non-brigade related JIRAs to look at. And then a note to everyone again that we do have a proposed VOLTA face-to-face meeting in Berlin. And so if you've already responded to the poll that is in Saurav's email, thank you for that. And if you have not yet responded, please do, so that ONF can properly gauge the participation level planned and proceed accordingly. With that, Andrea, I'll go ahead and let you take control, if you would, and kick off today's meeting.
Thanks, Julie. Let me find the presentation and share it with everybody. Can you guys see my screen?
Yes, we can.
Perfect. So thanks for having me at the TST. I'm presenting this proposal, but it's actually something that comes from the whole team here that's been working in Berlin for a few weeks now together, me, Hardik, and Amit especially. It stems from the work that has been done on a specific patch and some of the issues that we've been seeing with coordinating that patch to get into the code base. So the current issue is that the development across multiple repos needs to be coordinated when merging patches across the master branch, meaning that if we do not coordinate properly a feature that spans across multiple repos with multiple Gerrit patches, the system can be, if you get the code from the master branch, can get easily in an inconsistent state. And this could yield to bugs and issues and discussions and waste of time that is actually going to be resolved when every patch of a certain feature gets merged. At the moment,
can you characterize these types of features? Because the idea of the multiple repos is, again, they can evolve independently. So if we're seeing a large set of patches where that's no longer true, I'm just curious, can you characterize?
I can probably bring up as an the example of what was the VOLTA issue that we saw this happening on, and that stemmed this discussion. So there was this particular story, Vols 2463, which involved, as you can see, many set of patches across multiple repos: PyVolta, the OpenOLT adapter, the Protos, libgo, the system tests, the core, and VoltCTL. The issue there was that, as you can see from the screenshot, which I grabbed before everything was merged, there were a few patches that got merged, but the core one, the updates in the system tests, and VoltCTL were not merged. So that yielded an issue where developers were trying things expecting a certain outcome based on the patches that they have been seeing get merged, or that they were thinking, or they were expecting a certain behavior out of a certain set of commands, and that was not happening because there were pieces of this, namely, for example, the VOLTA Go core, that were not merged at all. So does that answer your question?
Enough mute here. I guess so. I mean, some of this is for instance, we could have merged the core before VOLTA Go, right? There is some order here that could potentially get those, merge these patches in order that wouldn't have invalidated system testing. It kind of does. Let's just continue. I don't want to derail
Okay.
too much here.
So the idea is that
Just one thing, like when I see something like that, it just kind of say that we're not really backward compatible.
And I think we're not in a lot of ways, right? I mean, there are some
Yeah.
changes that this one in particular was definitely a non-backward compatible change.
sure.
Yeah, it looks like that.
So in that sort of thing, it does just happen. You know, for example, I have that timestamp patch I'm working on that is going to touch almost every repository in the system because, you know, you make a protobuf change, it kind of percolates everywhere unless, I mean, often you could make the protobuf change in such a way as you persisted the old fields while adding new fields and then go back later and remove the old fields after you've updated everything to use the new fields. But it seems like a long way around to go to do those kind of protobuf changes. But maybe as we get more into production and into use, we'll have to be extra careful with the protos that we're not breaking them with the frequency that we are now.
I also think we should hopefully not be having proto changes as much. We should hit some threshold where proto changes are few and far between.
But the assumption here seems to be that master of everything should always work together, or maybe the assumption is that master, if you just run master of everything, that might be broken, but the released version of all the services should work together. Or maybe some set of released versions of services should work together, but then there's backwards, non-backwards compatible changes in subsequent versions that might break that, and so the new versions might not work with some of the old services.
I would say that, yeah. Go ahead. I'm sorry.
It's just important to like identify like what's the assumption.
Yeah, I mean, I don't think there should be an assumption that master works together, right? This is why we have the Helm charts. The Helm charts define a set of containers that work together.
Well, but
Other than that, all bets are off.
Yeah. So Andrea, is the assumption that you're having that developers should be working on master all the time, even if master may be having incompatible changes?
Well,
is that what you're experiencing?
to me, that is the only way we can develop new features spanning across multiple repos. There is no way you can develop features on multiple repos not working on master.
Right. So I guess what we're trying to figure out here is if someone is doing development and they have a checked out set of Helm charts and they're using like VOLTHA to do their deployment, they are going to be rebuilding whatever container they happen to be working on at the time. That might be multiple repos or multiple containers if they're making changes to the protos or the libraries that span. So one of the problems is the problem that when we make changes to those library repos, so mainly VOLTHA libgo and VOLTHA protos, it's hard to percolate those all through the system in an atomic manner so that they all get upgraded at once. I think that's what you're trying to get at, is that we need to take more care with that. Am I making a statement that's aligns with what you're thinking, Andrea?
I think it is. That's perfectly right. I think that the issue is really where we go and touch things that trickle across multiple repos because of their nature, such as VOLTHA libgo, the protos, that if you're making a change to just one container and it's self-contained and it's not an API change, that ideally should yield no issue at all. But if we're talking about something that spans across multiple repos, as is an API change, that means that every container needs to get rebuilt. And that means, for the same reason why we're building the containers while we're developing, that means that we cannot merge things in one and not in the others. And this is where this proposal comes in. We're not talking about making changes to one container. On one container, I would agree that you need to work on master on just that container, just that service, because that helps you to make sure that your change is not actually breaking anything else. But when a change comes in that is actually an API change, such as this one, such as the one Scott is working on, such as many others that we have, I do believe that that has to be in certain way coordinated properly, which we have not done up until now.
I think we've always intended to do it the right way, but in practice, it hasn't happened with the amount of patch backlog we have. But I totally am behind you there, Andrea.
As long as I don't hear the word Git repo, I'm okay so far.
No. I'm putting all the trust in humans in my proposal. So my proposal is really that the desired outcome is that a feature spanning multiple repos across multiple repos should be an all or nothing, meaning that all the patches go in at the same time or none do. So the first thing that needs to happen, and I think we've been pretty good at this, is that the patches for a certain JIRA are tagged with that JIRA at the start of the commit message. And now I'm proposing also a little addition with this X/Y, which is, oh, this is patch number 1 out of 3. I know this is 7 patches because it spans 7 services. This is going to be 1 out of 7, and it is 1 out of 7 to 7 out of 7. In JIRA, as we are seeing before, if you tag the patch set with this bracket vol dash number of the JIRA ticket, you get the JIRA ticket gets shown under the Gerrit reviews element all the different patch sets for that JIRA issue. So our reviewer needs to make sure before merging any of the patch sets associated to a certain JIRA issue that all the others are in +2 state. So my proposal is that the coordination happens between the reviewers and the people that can merge stuff, and that they look at the JIRA issue, and if all of them have +2, they put them in. Otherwise, they give +2 to the review that they have done, and they leave it there until all of them gets +2. Also, this could be tricky for the submitter because sometimes a review is easy to make and it gets done fast. Otherwise, a trickier review involving the core that is usually a piece of code that is fairly important and it's fairly difficult to touch. Need the reviewer, the submitter of the patch set needs to ping the reviewers to make sure that all of this happens in a timely manner. The reviewer, again, should check the JIRA issues for the patches without the +2 vote. If there are any of those, we don't merge it, and those need review. Also, I know that there is an issue where Jenkins cannot test patch sets across repos because of their interdependency. So to do that, once all the patches have a +2 vote on them, the merging should happen in a way for Jenkins to be capable of testing, meaning VOLTHA libgo, VOLTHA protos should go in first, then, for example, VOLTHA core, and then the VoltCTL and the outwards facing and the tests and outward facing patches. Does this make sense? There's no Git repo in here.
Yeah, Andrea, I think it makes sense, but I would propose one small change to this.
Sure.
One is that the changes to the library repos, so VOLTHA libgo and VOLTHA protos, because you're not going to get a Jenkins approval on those other repos, I personally, when I see Jenkins -1 verified something, I'm hesitant to give it a +2. So maybe this needs to be a two-phase commit where when somebody makes a change to those library repos, those get reviewed, and then there's a separate process, a separate phase where all of the things that use those libraries, all the other things that use those libraries get reviewed. I think if we did it in that order, it would be more likely that we would be able to get a good review on these, because you'd have Jenkins input on that. Does that make sense? Or are there other people who have thoughts about that?
Yeah, I think I kind of agree with Zach on this, that it's nice to be able to do it in 2 phases, though we do need to have sort of an expected time bound on these 2 phases, because you don't want the protos or VOLTHA libgo, running up versions ahead while someone has a feature that nobody's even looked at, and it may take 3 weeks to get it integrated. I think, that sort of thing has happened a couple times with the protos already, where we've, made a proto change with the expectation that the rest of it is coming soon, but the rest of it hasn't been reviewed yet, and it takes longer to get it through reviews than anticipated. So
that is why
yeah.
I am proposing that we keep it in 1 phase, because worst case, the protos don't go in. Those should be the ones that first go in for Jenkins verification. And what we should do, is somebody mentioned in our discussion, is a proactive review even with -1 on Jenkins, meaning that if you are on a patch that includes multiple on a Jira story that includes multiple patch sets, even that some have a -1, but you know that -1 is because of the VOLTHA libgo and VOLTHA protos presence, you should still review the patch even with a -1.
But the problem is you don't know that's the reason, right? You can make the assumption that the reason that it's got a -1 is because the other stuff wasn't there. But until it actually runs, you don't know that's the reason. It could actually be another reason.
Yeah, and the containers, if they're dependent on versions, they wouldn't even build, because, and that's somewhat problematic, because there are code level changes that need to be done to support new versions of the protos. And if those code level changes are because the Go mod and the Go, those files change depending on the version of the upstream library. I think it would be easier to do it in 2 phases, but I do appreciate the need to get patch sets through and get things to being code complete, so that it's just fixing up those sorts of things between the 2 phases if we were to do a 2-phase solution.
I mean, is this issue really about more that time boxing issue, right? So the first part of the proposal was have kind of X, kind of Y to tell how many patch sets are involved. We kind of already have that information, because they're also, they should, every patch set should be associated with the Jira.
Yeah.
So you can go to a Jira and see how many patch sets are associated with it, the X/Y. Now, if we want to propagate that to the commit message, that's not a terrible idea. It's now a manual process, and if someone adds an additional patch set, they have to go through and update every other patch set's commit comment to include that X, Y. Again, that information's kind of already in the Jira. It's showing what patch sets are associated. Now, the other issue seems to be a time box issue, i.e. we commit the library or we commit the protos, and then it takes weeks to get the rest of it completed. We have a general problem with that, right? It's not just when this type of patch set, it's all type of patch sets, getting them through in a timely manner. So I'm trying to understand the real, kind of the core of the problem. Because I think we have all this information, is it just we're not acting fast enough on the patch sets to get them through.
So maybe then the way of looking at this is we could do it in a 2-phase one, meaning get the protos in and reviewed, but only when all the patches are there. Meaning this, a Jira-ish story has all the patches for it. We see two patches, one for VOLTHA libgo and one for VOLTHA protos, for example. we review those, we merge those, but only if all the other patch sets that are expected with those, meaning code changes are there, those two get merged, and then we have a time boundary of a week to get the other ones in. I don't know if, am I making sense?
That makes sense to me.
I think a time boundary of, you know, like a day or two would be better than a week.
That I agree with, yeah.
Yeah, but I think it does make sense, you know, that at least I would say, I think at the very least, it should be necessary that all of the patches that comprise the feature are available at the time the first one's asked for review. I mean, you should not be saying, you know, please review my proto changes. By the way, I haven't implemented my my core change yet. Yeah. You ought to have implemented it all and tested it locally before you ask for these reviews in the first place.
Can an author? Well, there's two issues. They could either keep it as a draft until they've got everything done, and then promote everything from a draft to an actual patch set, or they could put a -1 on their own patch set until they're ready, or market work in progress. You know, market some way that way to say, look, I'm not ready for having this review. I think that's what we need, is some kind of clue that don't bother reviewing this right now because it's part of a larger group and I'm working on some bits of it still. That makes sense?
Yeah.
Would it be possible to have Jenkins give a specific failure if the version it needs isn't available? Like right now we use everything is in the vendor folder. So it should be able to build everything. The only issue is it's going to give a -1 because it can't find the dependency. It can't verify what's in the vendor folder. If that had a separate, sort of a separate flag, then we could know to review something. We could run the tests and lint as usual, and be able to review something before the proto changes or VOLTHA libgo changes were in. Is that feasible?
So do people typically update their vendor before the dependency has been merged? I usually wait until the dependency's merged and then do my vendor update, and you know then my submit with the vendor update. I usually don't do a sort of a proactive vendor update before the dependency's in. I mean, I'll do, you know, with the local libgo or local protos, but you really don't know for certain that that's copying the exact same thing in that, you know, Go mod vendor would have copied in, because I think Go mod vendor does remove things that you're not using from what it copies. It only copies in what's actually used, whereas the, you know, the local protos or the local libgo sort of copies a whole tree in.
Right. It's more that it would be good enough if that could run, like, if we could merge those in, that would be good enough to run the tests and lint. Because in general, you're not reviewing the vendor folder. If you see vendor changes, it's just like, oh yeah, the new version's going to get pulled in, and that's, you don't have to worry about it. The changes you're actually reviewing, if we did include the changes in the vendor folder using local protos or such, then we could start the review early, right? And you kind of do it with the assumption that we know we're going to have to rebase to the latest, but it should be cleaner to do that, and like that should be very smooth. That should just be, okay, I'm just going to bump the version number, run the update, and have Jenkins pass it.
So Kent, I know it's possible with Python to pull patch sets from Garrett reviews or Garrett submitted patch sets. Is that possible with Go? Can you do that with Go mod and pull in a patch set that's currently in Garrett, like one of the ones that would be on VOLTHA libgo?
You can, but it's very, very tricky.
So I wouldn't want to really heavily modify our CI process to do this if it's complicated. I feel like just reading the output of Jenkins is probably easier than trying to come up with a very complicated solution for what I think is probably a minor edge case that only comes up when these sorts of changes are being done. But I appreciate how it's desirable.
That's why I was proposing kind of agreement, word agreement, not having to put anything in the code. I like the idea of marking everything as work in progress until it's ready, and then when the protos and the libgo are not WIP anymore, work in progress anymore, they get reviewed, they get in, Jenkins verifies everything else, and we do the final review on everything else with a time boundary of a couple of days.
I think that's great. And one of the other things we can do is if there's a problem with the protos, then you release a new version that has your fixes. And then we ran into this in past projects where those library versions went up pretty quickly because people had minor fixes and other stuff that maybe they didn't test fully. And that's fine. It's better to have those in the dependencies than to release a bunch of new versions of the main code that uses the dependencies.
Okay. Maybe just to be aware of the time, I can summarize this and send it out on the email so we can reach a final agreement and then make an official announcement. Would that be a good outcome of the discussion?
I think so. And thank you for working on this, Andrea.
No problem. We'll do. Okay, Julie, I think you can take control back.
Yep. Thank
I'm
you.
going to stop sharing.
And then next, actually, I think we have Sarah. I believe I saw you online, Sarah. Maybe unmute. Okay, let me go ahead and bring my screen up then while we're getting Sarah on. Sarah, are you on the audio bridge?
I'm here, sorry. Yeah.
There you are. Okay.
Okay, so I'm going to share
Then
my screen now. Yeah.
Okay, thank you very much.
Okay, so the idea was to give folks a bit of an idea on, you know, we do these nightly regression tests. So how can you see the results? How can you figure out what you're seeing? So I just wanted to go through some steps, and I have my little cheat sheet here about what I want to show you. So this is kind of my script. We're going to start with the names of the pods and give people an idea, you know, what you're going to see over here. So in JenkinsOpenCode.org, you'll see multiple tabs on top, but the one we look at for our regression tests is what we call the VOLTHA 2.x tests, right? And the first thing you'll see over here, there's a number of names, but we want to focus on two pods. One's called the Flex pod, and the other one's called the ONF pod, or the ONF demo pod, right? There's a few other tests that are done over here that are periodic, that are done on BBSim. Okay, I'm not going to go over those right now, but I just want to look at the two physical pods that we use for nightly regression testing, the Flex one and the ONF demo one. The ONF demo one had some problems over the weekend, so we are still in the process of recovering that pod. So I'm not going to show you the results from this pod, so I'm going to focus on the Flex one, okay? So that's the first thing to note. That's the name of the pod itself. The next thing you will see is that there is a name that says default or 1T4G or 1T4Gem, okay? That's the tech profile that is being used. So there are different jobs that, bring up the pod, create a tech profile, and then go through a set of tests. So this is the default tech profile where we don't actually put anything in etcd. And we let, the basic 1T-conf1gem tech profile take over. And this one is the one where we actually put something into etcd. And that's what VOLTHA picks up. Okay, so the final thing to notice in the name is that it says master over here, another one that says master, and then a third one that says the release. So this is doing the last release, sort of regression testing over the last release that we did, which was VOLTHA 2.2, right before the winter break. And at that time, you can see that we had 5 regression tests, and that's what's running, okay? Whereas these 2 are running VOLTHA master, so the master versions of all the containers. And as I said before, this one is using 1T-conf4 gems, this one is using 1T-conf1 gem, okay? And the final thing to notice is that, for everything that is common, there is a master and there is a master test. Okay, so what's going on over there? Well, this is really just the build job, right? So if you go and click on it, it'll show you the Jenkins pipeline that's going through these steps, right? There's some configuration files for bringing up the pod, does cleanup inside the pod, installs a bunch of things, pushes the tech profile, pushes a status config in ONOS, reinstalls the OLT software and restarts it, reboots the OLT. And in our pods, we do have a switch because the eventual goal is to have 2 OLTs connect to a switch and then connect upstream to a VNG. So we do have a switch. Our switch is SDN controlled. In some other pods, we don't have a switch. That's okay, that's fine. So in this particular pipeline, we do have a switch. And so we do some switch configuration as well. So the build job basically prepares the pod for running your tests. And then if you go back and look at the actual tests, that's where we have a different pipeline that goes through the set of tests that we have. There's an initialization and some declarative post actions. But then these are the 3 categories of tests that we have, right? This should really read functional tests. So ignore that for now. But basically these are functional tests. There are some failure, recovery, restart based tests. And then there are some error scenario tests, right? We try to create an OLT twice. And so the second time it should just say, I've already done it. Why are you troubling me again? So something like that, right? So we go through a bunch of conditions, what we call error scenarios. So so coming back to my cheat sheet, what I've explained to you so far is, what are the pod names, how to identify them, what's master versus release, which one is being used for which tech profile. There is a build job, and I've shown you the pipeline for that. And there's a test job that I've shown you, and I've also shown you the pipeline for that. Now, how do you know what changed from one run to another? Okay, so let's go back to our test job. And then you can see that it runs, sometimes we run it through the day, during the day when we trigger it manually, but it also runs every night. So at 3:42 in the morning or late at night, you can see that there are runs at 3:42, many days. And sometimes we run it during the day as well. So how do you know what's changed from one run to another? So that's where you can see that some of them have no changes, especially if they run over the weekend. And then you can identify that in this particular run compared to the next run, there were 2 new commits. Okay. You can also see the details of that if you click on that, or you can go back and click on a particular run number 78, and you can see that there was only 1 change that went in. Okay, so that's one thing. Now I'm going to pick one of these runs, which I already have actually, and I'll show you a few other things that go in. So on the left-hand side, you will see a console output. Sometimes I have doubts on, what is the images that are running, right? You can see what changes went in compared to the previous run. But sometimes I just want to check on the particular image that is running of the containers. So what I do is I go to the console output and I scroll all the way down till I see, okay, these are the actual Kubernetes pods that are running over there. And just above that, I can tell, okay, I'm running OF agent master. These are the images of it. I'm running OF agent master, OpenOLT master, OpenONU master, a particular version of ONOS from VOLTHA ONOS's ONOS 2.2 branch, and so on, right? So that's where I can confirm, okay, this is exactly what was picked up, and that's what's running on this particular pod, on this particular run. Okay, so that's the console that I look at sometimes. I do look at the changes. And now I want to show you that how do I browse these results and look at the logs for these 3 kinds of tests that we do. Okay, so to look at the results, there are 2 kinds of logs. Okay, there's the one log that you see up here, which is basically the containers logs, and they're actually combined for all the containers. And I'll come back to that in a bit. But then what I want to see is the robot test logs, right? So there is a log.html down here that I click on for that particular run. And what it shows me is that there are robot test logs for these 3 kinds of tests, right? The error scenarios, the failure restart scenarios, and actual functional tests. So I click on the log next to the, let's say, the functional test. And what it takes me to is a different screen where it shows me these 8 tests that are part of the functional test suite right now. Okay. So any questions so far from anyone? Also, Suchitra and Andy, if I'm getting something wrong, please do speak up. Let me know. So any questions so far before I dive into any one of these tests and show you what's, how to parse that data? People can still hear me, right?
Yes.
Yes, we can.
Yep.
And I'll just remind everyone that you are automatically muted when you come on, so feel free to take yourself off mute for questions and comments.
Okay, thanks, Julie. Right, so, so I'm going to dive into what we call the sanity tests for the AT&T workflow. And this is what's going to look like, right? And you can bring up any of these tests and, you can dive in and come out of it and so on. But basically what it does in the sanity test is that it starts this test, it puts it into the log. There's a message that says, okay, I'm starting this test. Then it does some internal cleanup. But what you really want to see is what it does when it performs the sanity tests, right? So in this perform step, first it checks, is the OLT device actually in ONOS, right? Then it sets some internal variables for itself, and then it actually does the test for the number of ONUs, okay? So typically when you see something like this, in the range of the number of ONUs, so this is per ONU based tests. And in all our pods, we have 3 ONUs, 2 of them are on one PON port, and the third ONU is on a different PON port. Okay, so the validate ONOS step, basically, if you dive into it, what it does is that it's making a REST API call to ONOS and parsing the output that comes back from ONOS. If you look at it in JSON, it's a little bit hard to read, but there is one switch over here that is actually the physical switch. So let's ignore that for a second. And this other one over here, which is actually the sort of the logical switch represented by VOLTHA, right? That's its serial number. And it tells you that it connected 9 seconds ago. Okay. So the serial number is actually known to the robot framework because that's what it was configured with. So it's just checking in ONOS to see if the logical switch actually connected to ONOS or not. That's basically what happens in this validate OLT device. So I'm going to shrink that. And then move on to the actual sanity test, as I said, which is for per ONU basis. So I'm going to look into one of these ONUs and see what's happening over here. Again, some internal variable setting. But now I'm actually going to look into the ONU again through a REST API call to ONOS to see what is the port number in ONOS for that particular ONU serial number. Again, the ONU serial number is known to the framework. So it determines, okay, so this particular ONU port is 32. Actually, it's the uni port on the ONU that is 32, because really there are 5 uni ports, but we are only interested in the one that is live and connected to an RG. So we find that that one is port number 32. We then check if it's enabled, right? So so the test, basically polls ONOS to check if that port has been enabled or not. And you can see that the first time it polled it, it found that it was not enabled. But then it waited for a while and tried again. And the second time it succeeded to find that port was enabled. So if you dive in, you will see that the state of that port 32 is now enabled, right? And if you look at the previous step, I don't see it here, but basically I think there is there is a grep involved. So grep for enabled ports. So that didn't show up. So that's why it was empty in that particular step. So yeah, so you will find this kind of pattern in many places where it tries the first time and it fails, and then it tries again and it keeps trying up till a certain time that beyond which it times out and says, okay, I give up, and this test fails. So the second step of the sanity, and I'm going to shrink out again, was basically to verify that the ONU port is up and enabled in ONOS. And then the next step it does, and I won't go through each step, but basically what it's doing is now it's checking that, in the AT&T workflow, EA poll flows have been added for that particular ONU. It reaches out into VOLTHA and checks that ONU is enabled, active, reachable, and the OMCI state says OMCI flows pushed, okay? Then once all of that is done, it actually reaches into the RG and starts an authentication step. And it validates that in the RG, the WPA supplicant says that, hey, authentication succeeded. It then goes and checks ONOS to see if that particular subscriber shows up in the AAA users. So when both of these succeed, basically you're past the authentication step. And so now it's time to call on Volt add subscriber. So you add the subscriber, make the CLI call or the REST API call to ONOS and add that subscriber. That means subscriber flows will get programmed. And after that, it's all about doing DHCP, validating the DHCP succeeded, and you got an IP address. And final step is, you check the IP address on the client, and should it have an IP address, then you go ahead and do the ping, and you should be able to see the ping succeed, right? So it does a bunch of checks to see that the ping has succeeded. And it also goes back to ONOS and checks that the DHCP allocation shows the same IP that you got in the previous step when you were checking inside the RG for the DHCP. Okay, so you can always zoom in, zoom out of these steps. And at that point, you have now validated, you've gone through the sanity test. And at many times you will find that there is these collect logs, which I find very useful. What collect logs is doing is that it's actually, so we'll use logs in many places, okay? So you're looking at the robot test logs, okay? There's actually the container logs, and then these are logs that are collected from the CLI, either the ONOS CLI or Volt CTL. So for example, in collect logs, you can get a list of devices from VOLTHA. So you have to click on this log. So you can get a list of devices from VOLTHA. You can look at the ports. You can look at the flows. You can get the logical device also from Volt Kettle. And finally, in ONOS, there's a whole collection of things that you can grab from the CLI, like, what are the devices? What are the ports inside that? So these are the switch ports. Remember, there were 2 devices, and then this is the actual VOLTHA based logical device. So you can see that there are 5 uni ports per ONU, but only one of them is enabled. The -1 is enabled because that's what has an RG hooked onto it, and the other ports are disabled. These 5 are for a different ONU, and these 5 are for a third ONU, and then the last one over here is for the NNI port. So you can see, port level, then you can see flows, meters, a lot of other information that you can get from this collect log step. At the end of each test, so like I said, this was for one ONU, you do the same thing for the other 2 ONUs, and then your test passes. And at the end of each test, you will see a teardown step. So, you can pick any test, you will see a teardown step. And in that teardown step, there is also another collect logs, right? So there are logs that are picked up from, Volt Kettle and ONOS CLI in between the test, and also at the end of the test, right? So these are the robot logs, and hopefully I've given you a way to parse through them. And now when you actually want to see the container logs, so the way to do that, again, is to go back, so again, for error scenarios and failure scenarios, there's also basically a set of tests that you'll see the same robot logs. So there's one container restart test right now. There's 2 error scenarios right now. The number of tests is going to double actually very soon. So if you want to see what the container logs were, so you go back to the run, right? And I told you that this is where the container logs are. Okay, so again, for the error scenarios, for the failure scenarios, and the functional tests, you get these combined logs, right, for all the containers in this big file. There's also the OpenOLT agent logs inside the OLT, okay, and some sort of error report. But the easiest way to view these logs I've found is to click on the build artifacts, and then download all of these files locally, right? So you download all the files locally, you open them up, and then you can use whatever your best text editor or log viewer is to see the details of that log, right? So for example, we can do that. So I looked at the failure scenarios log. It's a relatively small one, so I'm going to open it up with just say text edit. And I think there is a part which says start. Whoops. I think there is a start test. Yeah. So you can see that, there is a start in this combined logs for all the containers. It's also across multiple tests, right? So the restart test, there is only one, but in the other log file where it's doing functional tests, there are logs for 8 tests. So each test at the beginning, there is a start test. And then I believe there is an equivalent, I think, end test. Yeah, there's an end test for that. So you can get an idea where you're, when you're picking up logs for which particular test. Okay, so far I've picked a test. I've shown you the steps of going through the sort of the robot test logs. And I've shown you how to look at, the collect logs, which is in the teardown step, but also in between the test for ONOS as well as VoltKettle. And then I've shown you how to look at the container logs, okay? Now I'm going to pick one of her broken tests and just to give you an idea of what that could look like. So back here, I'm going to go to this, let's say, I'm going to pick this one. So I can see that 11 total tests, across the 3 were tested. One of them failed. Now what I'll see up here is that I also see container logs for that failed test, right? So the sanity test in this particular instance had failed. Okay, so it's still there. This sanity test is part of the functional test suite. So in the functional test suite, you would have seen these logs, but also separately, you're seeing the logs for this sanity test. And if I dig in to see why that failed, okay, so now this can be all, zoom. So I typically like to zoom out first and see, okay, so 7 of these tests passed, but the initial sanity test failed. And what I can see is that the first thing that failed was that particular port never got enabled in ONOS, okay? And really the test fails right there, because if that port never got enabled, then EA poll flows would have never been added, right? And so the OMCI state would have never gone from MIB download to OMCI flows pushed. And authentication would never have worked because you never really pushed the flow down because you never really got the port to be enabled, right? So you can see that in the sanity step cases as well. So like I said, there were the sanity tests for three ONUs. you can see 2 of those ONUs did in fact successfully go through the whole sanity test, but the first one did not. And if I zoom in, so again, let me zoom out some of these things so I can, stepwise go through. So again, as I was going through the sanity tests, I see it checks that what is the ONU port in ONOS, that happens to be 32. And then it goes to that verify that that port is enabled, okay? But this verify that port is enabled, this is the thing that fails, right? And it tries like for 2 minutes. And after 2 minutes, it basically says that, it's just not getting enabled, right? So that's why it failed. And that's why everything else after that also failed, right? And I can check, I can verify. If I look at collect logs, remember this was port 32 that had failed to get enabled. If I look at collect logs and I look at the ONOS CLI commands, and I look at ports, and I look at that particular port 32, I can see it's disabled, right? Whereas the other ONU is enabled and enabled, right? So this particular port never got a notification from VOLTHA to change its state to enabled. And I can verify by then going and looking at the container logs to see if I actually get, where did that notification get lost, right? What happened in VOLTHA that never actually resulted in that thing turning enabled. So that's all I had. Any quick questions? We're almost out of time, but I've shown you a way to go through these things. And if you have any questions, feel free to ask on Slack or the VOLTHA mailing list as well. But that's all I have. Anything from anyone?
Okay, not hearing any questions at the moment. So Sarav, thank you very much for the presentation, demo walkthrough. And then I think we're basically out of time. It is top of the hour. So I'm trying to switch back to my screen, but it's not taking it at the moment. Here we go. So I'll just, we can review these handful of non-brigade related JIRAs offline, I believe. So just a pointer again to folks who are not on at the start of the call. If you have not yet responded to the poll that was in Sarav's email related to whether or not you'll be able to participate in the face-to-face VOLTHA meeting that's proposed in Berlin, please go ahead and respond to that poll. And with that, I think we'll go ahead and wrap up. Let me just ask quickly, any last comments or questions before we close the bridge today? All right, not hearing any. So thank you everyone for your participation. Thanks Andrea, and thanks Sarah for the discussion material today. And we will close today's meeting. Thanks everyone.
Everybody, take care. Bye-bye.
Thanks, bye-bye.